Welcome to the AtlantECO podcast, where we talk about the science behind the AtlantECO project, the Atlantic Ocean, and the human adventures experienced along the way. Here, we have conversations with guests from around the world who work together so that we can better understand, manage, and protect the ocean. So let's embark on the journey of AtlantECO and discover the world that lies above and beneath the surface of the beautiful Atlantic Ocean. In today's episode, we are going back to our exploration of the Atlantic Ocean as lived by scientists who embarked on the Tara schooner during the Mission Microbiomes, which is the latest expedition of Tara Ocean Foundation and one of AtlantECO's flagship expedition. I am happy to speak to Remi Laxenaire, who is chief scientist on Tara as the team crossed the Atlantic from Punta Arenas in Chile to Cape Town in South Africa. With Remi, we are talking about his experience of the crossing and explain what scientific questions the team was tackling during that leg. But first, let's get to know a little bit about Remi. So Remi, hi and welcome. It is a pleasure to speak to you today, and I am quite looking forward to hear about your adventure.
Hi, Iris. It's clearly a shared pleasure. And yes, I hope that through this recording we will make the listener a bit feel what it's to cross the Atlantic.
Nice. Yeah, so before we start, and as we do with each episode, we like to kind of get to know our guests. So can you tell us about yourself, about your connection to the ocean, how it started for you? And can you also tell us what your journey has been to get where you are today?
I'm in my early 30s, so I still think myself as a young researcher, specialized in the study of the physics of the oceans. So my goal is really to look at how dynamically the ocean moves and using especially remote sensing. So it's satellite data, so data that are taken from far, or like for this mission, in situ data via observation. And so since my childhood, I grew up in Reunion Island. So it's a small tropical island east of Madagascar. So I always have been in contact with sea, mainly via scuba diving and sailing, all this kind of thing. So when I finished my my school, basically, I directly started to do oceanography. As any researcher, I had quite a complex and strange, long path of university that bring me in many very nice places between Quebec, Cherbourg, so France, Normandy, Brittany, in UK, so in Wales, so and even in South America. So I had the opportunity to move a lot. After my PhD in Paris, I had the opportunity then to go in the US. It was in Florida. It was amazing. Unfortunately, we had the COVID there, so I could not stay as long as I wanted, but I came back where I'm now in Reunion Island, working closely with Parisian University and University of La Réunion to study the ocean via observation.
And today in our episode, we want to focus on your experience during one of the topic studies of Mission Microbiomes. And as mentioned at the beginning, you boarded Tara in Chile, and after almost 2 months at sea, you reached the shores of South Africa. So let's talk about this long journey. Can you tell us about this region of the ocean that was studied? What was so specific about it, and obviously important to get some information on? What scientific questions were addressed during that leg, and how it will contribute to increasing our knowledge of the Atlantic Ocean and its evolution? So a lot of questions to unpack for you there.
Plenty, for sure. Let's start by the idea of the Atlantic Ocean, because I think this leg is very important in this way. So when we look at the Atlantic Ocean, we see different type of boundaries. Obviously, we are all aware of the western and eastern one, which are continents, but there is also boundaries in the ocean. So south, when you don't have the Atlantic Ocean that reach Antarctica, there is another ocean called the Southern Ocean, a huge ocean turning around Antarctica. So this limit is, in fact, hydrological limit. It's kind of what we call water masses. So it's part of the ocean with properties that are different and are close one to the other, which is called fronts. And so one at the north of these fronts, it can be the Atlantic, and the south, the Southern Ocean. So the basic idea was to kind of close the budget of the study of the Atlantic, focusing on the southern branch. When we talk about the leg and so the journeys that we did, I like to see in all the microbiome projects kind of two main ideas. There is a long scale one, the continuous one that we do via underway sampling. So basically from Punta Arenas in Chile and Cape Town in South Africa, we did continuous measurements. So that allows to kind of have this southern limit. But also an overlay of this question, there is a study of what I like in a way to see as anomalies. Other legs went to focus on icebergs or on particular bloom or on particular event of outflow rivers. So they looked at specific objects and to see how these processes impact the community. And we did the same, but what we looked was dynamical structures. So the ocean is by far not steady. It moves a lot. And among all the different processes that happen, there is some that are particularly stable, coherent over time. And so that as they last a long time, they can have a noticeable impact. And so what we looked for were eddies. So eddies are kind of particular structure in the ocean, which are a type of water mass, which is ejected by a process that we want. Many different processes can happen there. But what happens is that you have a mass of water which is different from this environment. And due to the rotational effect of the Earth, it's reached a kind of equilibrium where the water particle will rotate fastest than they move. So what happens is that you have a kind of like in the atmospheric, like you have typhoons or this kind of thing. And what happens is that due to this rotation, you have water masses different from the environment trapped. So we wanted to look at these specific objects to see if the community inside, which were kind of isolated, planktonic community inside, are different to the environment. And in addition, what you have at the boundary is that you have a discontinuity between type of water mass. It's what we call a front. And the particular of the front is that there is a vertical motion. The ocean, you can see it as a lot of thin horizontal layers, very stable. And the velocities are by far highest on the horizontal than in the vertical. It's very, what we call stratified. And in this particular area, what you have is the vertical motion that can bring nutrients close to the surface or what can impact, in fact, the environment. So what we wanted to see is it possible by looking at this front to see that we can have a same community, but due to the vertical motion, they are in a water mass that change at a very high speed. So do they adapt? So it was this kind of two main idea of who are they, who are in the ocean, and how do they adapt quickly to the change of the environment.
Right. So yeah, so it sounds like quite a complex environment where everything moves in all directions, up, down, and away. Yeah, that brings me to my next question. How do you study this in this particularly dynamic environment? So what did you have to do? And I guess they were challenging conditions. So can you explain to us what you did?
That was the main complicated task because what we are talking about is change of temperature, salinity in the ocean. That's not something that you see. There is a second effect that you will have some mammals, some animals that can go in this direction or some slight change of color or some currents, but basically it's something that is invisible. As another difficulty is that it changes a lot. It can change a position of miles in weeks, So we started for 2 months. So in all the frame of the Mission Microbiome, I entered in this mission before being chief scientist by providing a tool that cluster all the satellite data available, interesting that had changed from every legs. And the goals was so people on boats had on near real-time information of the ocean and people on land at the same. And so we use the same tool. So we add, thanks to satellite data, continuous information of the state of the ocean. And so we left Punta Arenas knowing one main information: when we will leave, when we need to arrive, working closely, of course, with the crew because they adapt always at the time to go to the harbor. And thanks to that, we had the number of days that will be available to do science. And so what we've done, we had repetitive, daily at least, meeting of looking at the maps, talking together, working closely with the crew member, looking at, because as you are saying, we were in a very challenging states, sea states, etc. We were in the between the 40s roaring and the 50s furring, so it's very high winds. So we had all these different parameters to take into account: sea states, time to end, of course, which object can we measure. So it was a kind of continuous repeating until we are close to one object that seems stable. We have seems cool weather states, and so we went on it, and then it starts the idea of station. So I'm quite sure you will talk about that already in the podcast. But station, the idea is that we put a lot of bunch of instruments in the water, continuous one, and sampling of water, and so we try to adapt all this sampling to our need, sometimes reducing the number of protocols to have a more high frequency of sampling. So it's already adaptation. And the things to know is we went one time on the need. The thing is that we start the journey, we start the day, we don't know if the eddy is here or not because it's not by sea. So we start the day hoping a lot, and hoorah, we have the information that it's indeed here because sometimes it's below the surface. So yeah, it was quite challenging. And even one time we were on the eddy and it was not here. In fact, it moved a bit. So during the night we drifted, used online information, found it, and so adapt the station. So it was challenging for sure.
It was challenging. Yeah, it sounds like it for sure. And I'm glad to know that all that satellite data and daily, brainstorming helped you to actually find the eddy. You could sample it. And I can't wait to hear about the results at some point in the future. It will take a while, but it will be very interesting for sure. Yeah, so each of our scientific studies, so in the Mission Microbiome, it is dedicated to a woman who is or was involved in marine sciences, and in this case it was dedicated to Remi Laxenaire. Can you tell us a little bit about her and her contribution to the field of marine sciences?
Yes, with pleasure. So I will be honest. I'm honest. I didn't know her before the start of the leg and all the different information. That's why we decided to dedicate these legs to such a scientist. So even myself, I need to learn things. And in fact, I knew her theorems, but I didn't know she was a woman. So Remi Laxenaire, she was so from end of 19th, beginning of 20th century, physician, mathematician, German. And I would say that there is two main important things to understand about our journey is that first, she was in the very difficult, it was very hard to be a woman scientist at her time. And she had a very hard journey across science from university with thousands of student men and only 2 women. Even she had to work as a professor during more than 10 years without being paid, without being identified as one. It took so much time to be able to be certified by the other community, by male men. So it's her journey by itself is amazing, and she was Jewish. So in 1933, she went through out of the university. She had to go in the US. So even her life by itself is kind of amazing how courageous she was, and it's kind of a story of era. And from the science, what she did, it's very mathematical and algebra. The main idea is that when Einstein did the general relativity theorem, some identified a paradox, what's called invariance, saying that law of physics are not invariable. So what she did a huge work, mathematical one, and she showed that it's the case. So what does it mean? It says that if you have a law of physics, let's say, or you launch a ball, it doesn't depend where and when you do that, because it's invariant. And it's the same for something that we measure. So we are in the field of theoretical physics and mathematics. And if it's not proved by math, it was not the case. So she showed that and had a very, very nice, she impressed Einstein, to say. So we wrote a lot of things about her. And after that, during research, she came looking at different objects, algebra objects, so mathematical, which are called by her name. And the link to the ocean, I like to see it is that what we look, it's a leg what was particularly linked to physics. And what we looked was turbulence, because what we looked eddies and this kind of thing is called large scale turbulence. And there is many law of physics. And the idea that I have is it says that if we see something at this strange place with the same parameters, it's invariant, so we might see it elsewhere. That's a way to see.
Nice. So a long shot connection to the ocean, I guess at the basis of many calculations and theories and studies. So amazing. I didn't know about her, so thank you for bringing her to my attention for sure. We'll put a link to her profile page so that everybody can learn about that amazing woman. Yeah, so if we go back to your own experience on board of Tara, and that will be our closing sort of question for our conversation today. Can we talk about your personal experience on board? Can you share what it was like for you, about the life on board and the memories you've brought back from that region, and the people that you shared the journey with?
I have so many things to say. In fact, I will start by the idea of Tara by itself. What I bring back with me, the most important one, is what it's to live and to work on this kind of boats. I had the opportunity to be on plenty different boats, larger one, and this one is very particular in this way. We were 12 during 2 months. It's rather a small space. So, and we had to do everything together, work, live, clean, everything. And so we are as much colleagues, but more importantly, I would say boatmates, the similarity of housemates. So it really impacted me, and I loved it a lot. And linked to that, I don't know exactly if it's linked to the fact that we were on the Tara and maybe due to the fact that I was chief scientist, or just because we kind of changed our mind of this kind of thing, and it's a good idea. But I kept a lot in mind that we traveled a lot to come here, even if it's a sailing boat, it has a lot of climate impact, even if it's 12 people that dedicate 2 months of their life to be on this boat. It's also all the people that are around all this kind of mission preparation, both in the scientist team and the foundation of Tara. So all this effort. So it was a lot of energy and I felt that it was a shared one to make this mission a success. Every time we go and see on science, we know that if we don't have a measurement, we cannot say we will come back, because the time is one of the main factors. And really, it was amazing to me to see all these 12 people amazed by the environment. We were in such a great place, but also very in time of station, in time of mission, in time of preparation, very dedicated people that spend a lot of energy, and it creates a good friendship. So all the human parts, both in life and work, both all this kind of the Tara marked me for sure. After that, yes, we were in such a great place, of course. Left from Patagonia, it's a lot of postal card picture in my head. We had the opportunity to stop a few days in South Georgia to see a lot of penguins, seals. We saw many animals even at sea, because when we looked for these eddies, these fronts, when there is this vertical motion, there is life. So many whales, many albatross. So all the animal community, and even when we put a net in the water, what we sometimes for the largest grid of the net, we had animals that we can see via microscope and all these kind of things. So life was amazing, like wildlife, and you feel so small in front of these elements, all this wind, all these giant waves, change of color, all this landscape. The sky was amazing. In some time, you think that the human, apart us, closest human would be on the ESA station,
Yeah, so I had the pleasure to talk to a lot of people that were on board, and I was on board of Tara a little bit, and I have heard about South Georgia so much. I think that was one of the most impactful moments of the entire mission for a lot of people. So at least those people that were on board at that time. I can only imagine the scenes that you were witness to and the sort of landscapes and animals.
No, it was very good. And the thing also is that due to the COVID situation, it was not easy for all the sailors, because normally when they stop on different cities, they have possibility to walk around, to go out of the boat. And it was not the case due to this situation. So this South Georgia stop was their pleasure, and to be part of that, we were extremely lucky for sure.
Yeah. So, I have to thank you today for your time, Remi, for sharing those amazing memories with us, and for, taking the time to actually explain what goes on in that region. I think it was very interesting, and I can't wait to hear about what you found out about that very dynamic region. And thank you again.
Yeah, that's my pleasure. Thank you very much.
We hope that you've enjoyed today's episode and look forward to seeing you next time. You can follow the AtlantECO project on our website on www.atlanteco.eu, and you can also find us on Twitter, Instagram and Facebook. All the links and information on the project and on today's episode is in the show notes. AtlantECO is a project funded under Horizon 2020, a European Union research and innovation programme.